Hey guys, it's Miss Johnson and I'm here to bring you our fourth notes video for Unit 2. Unit 2 Notes 4 is on solving systems using substitution. So we've already talked about how to solve systems by graphing and how to solve systems by eliminating one of the variables. We've also spent a lot of time talking about how we can't solve two equations with two variables. We need to somehow take those two equations and manipulate them so that they're one equation with one variable and then go back and substitute for the other one. So today is just yet a third method that sometimes works better and more efficiently than using the elimination method that we used in notes 3. So solving systems using substitution, we've got a few steps that we are going to write down here, about 4 of them. The first one is we need to solve one of the equations for one of the variables. We need to isolate one variable. Get one variable alone. Okay. So one variable needs to be isolated. It doesn't matter which variable it is, and it doesn't matter which equation it's in. One of the equations has to have one of the variables alone. It could be x or it could be y. Then the next step is we're going to take the expression that's equal to that variable and substitute it into the other equation. So that's where that second equation will come into play. When we do that, we're left with one equation with one variable. That's how we're manipulating getting rid of that second equation and second variable, because we know we can't solve two at the same time. So then we'll have one variable left that we'll have to solve for. And once we solve for that variable, substitute it back in and get the other one, just like we did in elimination. Okay, so it probably sounds a little bit tricky, but we're going to do lots of examples together. Before we do some examples together, there's a couple of things that I want to talk about. We have other possibilities than just getting one solution. Most of our equations have had one solution, where we've come down to that point xy, and that's considered one solution because it's one point on the line. We also have the possibility of having infinitely many solutions and no solutions. Infinitely many solutions is when you have both variables cancel out. Both variables drop out of the equation after you start manipulating it into try and solving it. If you are left with a true statement, what I mean by true statement is you'll have something like 0 equals 0 or 10 equals 10. We know that those are both true. Then you actually have infinitely many solutions to that system. What that means is those lines are actually essentially the same line. Every solution that's on one line is also on the other. So there's infinitely many solutions because you can plug any point into either equation and it will be true for both. And then we also have a possibility of no solution. If both variables cancel out and what's left is a false statement, so you end up with something like 0 equals 3, we know that is not true, false. So we can call that the not equal to sign. Then the system has no solution. So if you're left with a false statement at the end, then you've got no solution to that system. Okay, so let's take a look at number 1. In number 1, I have the system x plus 2y is equal to 8, and x equals 2y plus 36. Now, when we were solving by elimination, we would want to make sure that our x's, y's, equal signs and constants are lined up. In this case, our equal signs aren't lined up. So what I want to recognize is the fact that in this second equation, I've got this x equals. Okay, I have a variable by itself equal to this whole expression. So what I'm going to do is, since I know that x equals that whole expression, I'm going to take that whole expression and I'm going to substitute it in for x in the other equation. So I'm getting rid of this x and I'm putting the 2y plus 36 in its spot. I'm literally substituting. If you think about the word substitution, when we hear the word substitute, we think teachers. A substitute teacher is a teacher that comes in for a teacher who's absent. So if I'm gone one day, I'll have a substitute come in and take my place. Equal value, both licensed teachers, both are teachers, both are filling the same function. One is replacing the other. So Miss Johnson is gone, the substitute is in my spot. We're not both there at the same time, one is replacing the other, if that makes sense. So we're going to replace that x with the 2y plus 36, and then rewrite this whole top equation. I have 2y plus 36 from this bottom piece that I'm replacing the x with. I still have the rest of it as it stands, plus another 2y is equal to 8. Now I have one equation with one variable. I have some combining to do and some solving to do, but I know how to do that, so that's what I'm going to do. 2y plus 2y is 4y, plus 36 is equal to 8. Subtract your 36, and you get 4y equals 8 minus 36, which is negative 28. Oops, sorry, 28. And then divide by 4. Negative 28 divided by 4 is negative 7. There's my y value. Okay. Now, this is only part of our solution, and we know that. We know that from graphing and from using elimination. There's two parts to the solution. I need to go back and get the x variable. So I'm going to take it and I'm going to plug this y value into my original bottom equation because I already have x alone. So all I'll have to do is simplify. So I'm going to have x equals 2 times negative 7 plus 36. That's x equals negative 14 plus 36, or in other words, x is equal to 22. So my solution here is 22 comma negative 7. That is substitution. So a big piece of it is the same, all this stuff at the end where we take the first value that we found, plug it back in, get the second value, get the second variable. It's just the starting points that are a little bit different, okay? So let's look at number 2. 2x minus 3y is equal to 2. X plus 2y is equal to 15. So I recognize that my x's, y's, equal signs, and constants are lined up, so I could use elimination here if I wanted to. But I also recognize that this x value right here has a 1 coefficient. That's what you want to recognize with substitution. Anytime you have a 1 coefficient, look for 1 as a coefficient. Anytime you have 1 as a coefficient, your life is pretty easy with substitution. So what I'm going to do is I'm going to move this 2y over so that x is alone. Now x would be equal to everything else. So I get x equals negative 2y plus 15. And this piece, since it's equal to x, can be plugged in right there. Now be careful when you're substituting. You're only replacing the variable. The 2 stays. The 2 is a coefficient out front. That's not the variable. You're only replacing the x value or the x variable here. So that 2 that's out front is going to stay, and then I'm going to put this whole piece in the spot of x. Negative 2y plus 15. Then minus 3y is equal to 2. So the rest of the equation I just kept the same. Minus 3y equals 2. All of that stayed there. Now I have some substituting, or I have some distributing to do. So when I do that, I have negative 4y plus 30 minus 3y is equal to 2. I need to put my y terms together. Negative 4y and negative 3y, they're on the same side of the equal sign, so I'm just going to combine them. Negative 7y plus 30 is equal to 2. Subtract your 30. My pen is kind of dragging today. Sorry about the poor handwriting. Negative 7y is equal to negative 28. Divide by negative 7, and I end up with y equals positive, because a negative divided by negative is positive 4. So now I need to plug that back in and get my x variable. So I'm going to plug it back into this equation right here because that's where I have x alone. So I have x is equal to negative 2 times 4 plus 15. By the way, it wouldn't matter what original equation you plugged it into as long as you plug it in for y and get your x variable. you should get the same value each time. So negative 8 plus 15, and that gives me x equals 7. So my solution is 7, comma 4. All right. Number 3, so I have 7y equals 26 plus 11x, and x minus 3y is equal to 0. So I have all sorts of mess going on here. This doesn't look good for elimination or substitution, but what I do notice is that there is a 1 coefficient in front of this x value. So I can very easily take this negative 3y term and move it to the other side of my equal sign just by adding. So that gives me x equals 0 plus 3y, which is just 3y. I don't need to write the plus 0 behind it because it doesn't mean anything. And now, since I have x equals, I can take the 3y and I can plug it in for x right there. So I will have 7y equals 26 plus 11 times 3y. That's 7y equals 26 plus 33y. And then you have a couple choices. You can take the 7y and move it over here and be left with nothing, or you can take the 33y and move it back there, and then you don't have to worry about that 0. Usually I say move the smaller one, but since there's nothing else with the 7y, I'm going to take the 33y and move it over there. Saves myself a step. 7 minus 33 gives me negative 26. So negative 26y equals 26. And then when I divide by negative 26, I end up with y equals negative 1. Plugging that back in, I'm going to plug it back into this equation right here because that has the x alone. X is equal to 3 times negative 1. That's x equals negative 3. So my solution is negative 3, comma negative 1. Let's try the next one, number 4. I have y equals 3x minus 4 and y equals 4 plus x. Now this equation, this system is pretty friendly because both equations are set equal to y. These are some systems that you probably saw in 8th grade. Since I know that y equals all of this, I can take that piece and plug it in for y down here and essentially just set the two equations equal to each other. 3x minus 4 equals 4 plus x. Okay, so I took this piece that was equal to y and I plugged it in for y down there. Remember, when we plug things in, we get rid of that variable and put the expression that's equal to it in that spot. So I have 3x minus 4 equals 4 plus x. I'm going to subtract this x so my variables are on the same side. And then I'm going to add this 4 to put my constants on the same side. 4 and 4 makes 8. And then divide by 2 and I get x equals 4. Go back to one of the original equations. Doesn't matter which one, you should get the same answer for both. Y equals 3 times 4 minus 4. That's y equals 12 minus 4, or y equals 8. 4 comma 8 is my solution. All right, let's flip over to the back. We're going to talk about 2 more practice examples of like this, and then we'll talk about some word problems. So number 5, 3x minus 6y is equal to 6, and 2x equals 4y plus 4. All right, so that is kind of a yucky system. Nothing is lined up. The equal signs aren't lined up, so that's not going to help me. And none of those are opposite coefficients anyways, so I would have had to do a lot of multiplying if I were going to use elimination. If I use substitution, I don't see any place that has 1 for a coefficient. However, I do recognize that this equation right here, this bottom one, I can divide by 2 on both sides, take that 2 out, and then I'll have that x variable alone. 2 divided by 2 is x. Is 1x, which is what I want. That's my goal. And over here on the right, 4 is divisible by 2, and this 4 is also divisible by 2. So 4 divided by 2 is 2y, and 4 divided by 2 here is 2. Now I have the x variable alone. Now I can take the 2y plus 2 and plug it in for x right there. So that's what I'm going to do. Keep the 3. That coefficient doesn't leave. So 2y plus 2 goes in for x, minus the 6y equals 6. That's the rest of the equation that stays the same. So now I need to distribute this 3. That's 6y plus 6 minus 6y equals 6. Put your y terms together. 6y minus 6y is 0y. So 0y, I know, carries no weight because 0 times anything is 0. This dropped out. So I purposely got rid of the x. I wanted to get rid of the x by replacing it with that. That was my goal. But in doing so, I also got rid of the y, which tells me that I'm left with just this 6 equals 6. And this is the point where you ask yourself, is that a true statement or a false statement? And in this case, it's true. 6 does in fact equal 6. So you're done. You know that this is infinitely many solutions because your variables both dropped out and you were left with a true statement. So you have infinitely many solutions. Let's take a look at number 6. 2x equals 7 plus y, and 6x minus 3y is equal to 24. I see, again, a yucky system that has nothing lined up where it should be or where I would want it to be for elimination. So I'd have to do a lot of work to make elimination work. But substitution, I recognize that there's a 1 in front of this y, so I can very easily subtract my 7 over to the other side, and then I'll have y alone. So when I do that, I end up with y is equal to 2x minus 7. So that helps. So now I've got y alone. Now I can take this. It's going to be a hard one to see, so yellow here. There we go. 2x minus 7 and plug it in for the y right there. Keep the negative 3 that's in front. You're only getting rid of the y. So get rid of the y and put 2x minus 7 in its spot. 6x minus 3 times 2x minus 7, 7 is equal to 24. So now I solve that, and I end up with 6x minus 6x plus 21 is equal to 24. And again, check it out. 6x minus 6x drops out. So I purposely got rid of the y by substituting, and in doing so, I got rid of the x term as well. So I'm left with 21 is equal to 24. And now we ask ourselves, is that true or is that false? And in this case, no, it's false. 21 does not equal 24. So your answer here is no solution. All right. We're going to pause our video here. I'm going to start part 2 of our video with the remaining 4 word problems after that. So thanks for listening, and I will see you later.